Okay, so for problem number 9, it says determine whether the triangles are similar. If they are, write a similarity statement, explain your reasoning. So I'm going to try to prove this by angle. Why? Because I could do side angle side, I could do side side, but if you look at the two figures they've given us, I have zero information on the sides. So that means I can't do anything here and I can't do anything here. So by just I'm kind of forced to see if they're similar through an angle theorem of similarity. So one thing I notice is that angle A, the measure of angle A equals 90 degrees. That's what this little square means. The measure of angle B also equals 90 degrees. Okay. So that means that the measure of angle A is equal to the measure of angle B. Well, that's one angle that I proved to be congruent. So then, on a right triangle, these angles have to add up to 90. So what do I add to 35 to make it equal 90? 55, right? So let me show you where that comes from, okay? Because I'm just saying it. I want you to see it. All three of these angles have to add up to 180. So to find this angle, I just say 180 minus the quantity of the sum of these two angles, right? So I'm going to say 90 plus, got stuff on the thing, plus 35. 55. So this is 55. By the way, if I were to do the math for this one, this angle right here would be 33. So in other words, the measure of angle H does not equal the measure of angle Z. The measure of angle M does not equal the measure of angle N. So then I'm going to say cannot prove. Cannot prove by angle theorem of similarity or postulate. So a student asked me yesterday, what's the difference between postulate and theorem? It's very formal, and at the high school level, it doesn't really matter, but I noticed that when they write these high school textbooks, they use them interchangeably. Really, there's no difference, but I suppose if you were a graduate student, you could have a healthy discussion about the differences between those two terms. Okay. I'm afraid if I define the difference between the two, it might confuse you guys more. I just want you to know that when we prove similarity, that you have to have two congruent angles. If you can find two congruent angles by the very nature of the fact that the triangles add up to 180 degrees on the interior angles, when you have two, you can find the third. In other words, if two angles are congruent, so is the third. Remember that? That was one of the theorems that we covered at the beginning of the school year. So if the angles are congruent, then we know that they're similar for sure. So moving on to problem number 10, this is the last problem for this worksheet. We need to determine whether RST or LMN is similar to ABC. Now they've given us all sides. So I have nothing but information on the side. So we're going to try to solve this with side. I suppose I should point out that you might consider side angle side. However, do we have any information on angles? No. So I got to cross that off the list, and the same with the angle theorem or postulate of similarity. Okay? So then which one is it? Well, what I'm going to do is I'm going to look at ABC. If they're similar, then they're proportional. If they're proportional, they have a scale factor. So I look at the shortest side on ABC. It's CB or BC, however you want to think of it. And it's 14. So then I'm going to go to RST. Their shortest side is 42. Now, if you're really good at math, you'll see that 14 times 3 equals 42. Okay, but we got to see if it corresponds. All right, so then I look at the next side, which is 16. 16 times 3 is 48. And then AB is 19. 19 times 3 is actually 57. So what I'm going to do is I'm going to take the first two letters, AB, put them over the last two letters, BC. And then I'm going to take the first two letters of RST, RS, and then the last two letters, ST. So I know the numbers work. But they're saying we got to be careful and we got to check the labels. So I got to make sure that I have the corresponding parts. In other words, A corresponds to R, B corresponds to S, B corresponds to S, and T corresponds to C. That's based on R corresponds to A, S corresponds to B, T corresponds to C. So now it's just a matter of plugging it in. If I plug it in, AB is 19 over BC, which is 14, is equal to RS, which is 57, over ST, which is 42. Now, if I cross multiply this and they're equal, in other words, the left-hand side of the equal sign equals the right-hand side, then I know that they're similar. Let's see. 14 times 57 equals 19 times 42. I'm going to plug that in the calculator. I don't even need to do that because I know that 14 times 57 is 798, and 19 times 42 is also 798. So they are congruent. Oops, I'll slide it up so you guys can see it. That'd probably help. Okay? Now, if I were to do that with the third side, I could find a third side. In other words, I could plug in the third side and it would be congruent as well. Okay. Or proportional, which would, congruent's the wrong term. I meant to say similar, right? They're proportional. In other words, 14 times 3 equals 42. 16 times 3 equals 48. 19 times 3 equals 57, right? So 14 is CB, 42 is ST, so they correspond. These are all the side lengths of ABC. These are all the side lengths of RST, and this is what we call the scale factor. Okay? Any questions?